Welcome to our 9th video. This one's talking about our various properties of liquids. The first property we're going to talk about is viscosity. The resistance of a liquid to flow is called viscosity. Typically when you're thinking of things with high resistance, you think of honey or sometimes syrup if you haven't warmed it up. Things that flow very slowly. The greater the viscosity, the more slowly it flows. So honey would have a higher viscosity than water. Viscosity depends on the intermolecular forces between molecules and on the overall shape of the molecules, though we're mainly focusing on the first one. But that means, though, that longer molecules tend to have higher viscosity. It actually is, they basically become tangled, if you will, on each other. That normally deals with really long covalent organic molecules, but we're not really getting into those a whole lot. So mainly deals with the intermolecular forces. Typically, this will decrease with increased temperature. Like when you warm up syrup, it flows better. And that's actually because the increased kinetic energy from the temperature helps the molecules to actually overcome the attractive forces slowing them down. So the stronger the force is, the more viscous it is, meaning the slower it will go. Another property that we can talk about is surface tension. Molecules close to the surface of a liquid are pulled basically away from the surface by the intermolecular forces of the intermolecules, thus actually decreasing our surface area of the liquid. Basically what it's doing is trying to pull these down. And so what ends up happening is you kind of end up tightening up the surface and thus decreasing your surface area. The reduction of the surface area ends up packing those molecules a lot closer together, which increases the force that's required to separate them. Surface tension is when you can you can float a paperclip, or you can put things on water and they'll actually float instead of just falling through water. You've actually got this tension buildup that can kind of hold them there. And therefore, the stronger the intermolecular forces, the stronger the surface tension of the compound. So, for example, if you got something with hydrogen bonding, like water, it'll have a lot higher surface tension than something with just dispersion forces keeping it together. So, a couple of terms. A cohesive force is an intermolecular force that binds molecules to one another. Think of the word cohesion, when you're actually having things sticking to each other. An adhesive force is what binds a surface to another surface, or actually a substance to a surface. Adhesion, think of glue, when you're adhering something. Adhesion is what keeps water on windshields, if you will. So, when a small diameter kind of glass tube, they're called capillaries, are placed in water, water actually starts rising up the tube. It's kind of freaky. So, the rise of liquids up very, very narrow tubes is called capillary actions. And this is one more trend that can actually be explained by intermolecular forces. And it'll start dealing with cohesion and adhesion. Those will come in handy. The adhesive force between the liquid and the walls, which kind of tries to keep them together, tends to increase the surface area of the liquid. It tends to start pulling the liquid basically towards the walls, if you will, thus kind of almost stretching it out, trying to keep it near the walls. The surface tension of the liquid, which is more of a cohesive force, tends to try to reduce the area. So what happens is you've got water being pulled towards the capillary and then kind of back towards the middle, but they're basically pulled up higher and higher by the adhesive force, and thus water is basically pulled up the tube by those forces. Well, liquids, not just water. Our last property that can really be explained by intermolecular forces is a liquid's boiling point. Now, this one you're probably most familiar with. So boiling point, again, just the temperature at which the liquid will start boiling. So the stronger the intermolecular force then, the stronger the molecules are actually held together. Thus, the larger the amount of energy is actually required to overcome those forces. That should make sense, but basically the stronger the bond, The stronger the force, the stronger they're held together. The more energy we actually need, then the higher the temperature has to be to boil the liquid. Therefore, the stronger the force, the higher the boiling point. That summarizes our intermolecular forces of liquids, well, the properties of liquids. We got viscosity. The higher the force, the higher the viscosity, which means the slower it flows, or the more resistance to flow. We got capillary action, which is liquids rising up a tube. We got surface tension, which is basically you being able to kind of place things on water, if you will. And then we had boiling point. Thanks for watching.